Yeah, but have you ever ran your face into a wall at top speed while
Okay,
missing a friction if you're
so
watching
when you
video?
get to question number 4, similar to this, you have a spring that's 5.6 centimeters long when it's at equilibrium. So I'm going to take a 0.2 kilogram mass, something like this, and I'm going to hook it up, and I'm going to tell you that the new length becomes 15.6. You want to sketch a graph. This doesn't have to be done on another sheet of paper. You can do it off to the side. And you're going to graph elongation and force, not length. Okay? Elongation and force. You find the spring constant, how much work is done. Okay? And then we're going to put on an additional 0.3 kilograms. When you get to number 6, why I picked purple crayons when I typed this problem, I don't know, but at the time it seemed like a good idea.
A box
So,
entirely of only purple crayons.
just purple
That
crayons.
sounds delicious.
Don't know why, but at the time it seemed like a good idea.
It is a good idea. Very good
Are
idea.
they like magic crayons?
So-
Or like Harold?
Harold.
Now, the other thing that happens is that we leave friction out of this whole thing because that just gets annoying. Okay? So, the box of crayons is moving along. Here's the spring, okay? And this thing is going to compress this. So, what are the 2 types of energy that you're going to have?
Potential.
Us and
Key.
KT, right? Now, when you get to number 7, Jerry the mouse is on a skateboard, combined mass, excuse me, 0.5 kilograms.
Many blessings.
So here, let me kind of give you a visual on number 7. So here's the spring,
Per meter.
and we're gonna push this back like this. Are you gonna do work?
Yes. Sure.
Now, when you let go of it, what's it gonna do?
Something.
Do work.
Change into
Kinetic.
kinetic, perhaps? So,
Do something.
then the spring is
Right.
released. What velocity does Jerry have when it takes off from the spring? Then Jerry's going to go up a half pipe like this. You're ultimately going to try and figure out the height of Jerry going up the pipe. Okay? So, what type of energy are you going to have at the beginning?
Potential.
What kind?
Spring.
Us. That's going to change into,
Kinetic.
Kinetic energy.
and the kinetic energy is going to change into
Ugh.
us.
Ugh.
Okay?
Ugh.
Ugh.
I agree.
When I look at this problem.
Now, when you get to number 8,
Us.
let me kind of
Us
give you a
good,
visual on number 8.
Ugh.
So, you're going to go bungee jumping, okay? So, imagine this, you're on top of the bridge.
I've always wanted to be an apple.
You're going to fall for a certain distance before the cord begins to stretch, okay? So, you're going to be in free fall for a little bit. Then that cord is going to begin to stretch, and then you're going to store potential energy in the spring. So, here's what you've got. So on this one, you're told that, and this actually, when I took the kids a bunch to Africa, they ended up doing this. So, from the top of the bridge where you brought to rest, this is 31 meters.
It's the same thing.
So the entire length is 31 meters. But the cord has an unstretched length of 12 meters. So you're going to fall for 12 meters. At the end of that time, the cord's going to begin to stretch like this. So the first thing you want to figure out is K. So let me give you a hint. Imagine that you reverse the process. Imagine that you take this person down at the bottom and you lift them up to a height of 31 meters. What type of energy are you going to have?
Potential. Gravity.
Ugh, right? So the ugh that you have lifting it up is going to equal the us value that you're going to store in the spring. That will allow you to calculate the value of K. Okay? So set ugh equal to us. Okay. I'm done. You're on your own. This would be a good time to get caught up, Gap Sean. You have like 15 minutes.
Yeah, I'm pretty close. I'm
Okay.
on the, I'm almost in the problems.
I have
Okay.
something at 6.
All right, Cohen.